The institute was founded in 1949 and operated until 1965 as testing station for mining safety. During the 65 years of existence, INSAMEX has seen a continuous development, both from the point of view of the research domains and of its material base. Nowadays, INSAMEX is organized and operates as National Institute for Research and Development in Mine Safety and Protection to Explosion, having the statute of national authority. INSAMEX performs basic and applied research, technological development for the regulated domains for national public interest on the evaluation and prevention of risks which may occur during the operations performed in atmospheres with toxic and explosive hazard, including the use of explosives, environmental protection within the areas adversely affected by mining and related operations, testing and certification of equipment, training and certification of staff, rescue operations and operations related to mining closures, together with the development and implementation of regulations related to these operations. Department for Safety of Installations and Explosion-Proof Equipment. This department comprises 3 research laboratories: Laboratory for High Power X Equipment, Laboratory for Electrical Low Current X Equipment, Laboratory for Non-Electric X Equipment, Electrostatic, Materials and Personal Protective Equipment. Test stand for flame-proof enclosures. The test stand for flame-proof enclosures is used for performing tests in explosive mixtures upon equipment with flame-proof enclosure type of protection. This stand comprises 2 explosion chambers with a capacity of 1 cubic meter, respectively 3 cubic meters, a device for testing the explosive mixtures, a Servomex oxygen analyzer, piezoelectric pressure transducers for measuring the explosion pressure, load amplifier, piezoresistive transducer, piezoresistive amplifier, 2 oscilloscopes for viewing and recording pressure variation in time, humidity temperature transmitter, data acquisition multimeter, a high power supply and spark plugs. The stand is used for performing tests in explosive mixtures in accordance with the requirements of the European Standard 60079 Part 1, being used for performing the following tests. Test for determining the maximum explosion pressure, reference pressure, through which there is determined the maximum explosion pressure. Overpressure test, through which there is tested the capacity of enclosure to withstand to overpressure. Test for non-transmission of an internal ignition, through which there is tested the capacity of the equipment's enclosure not to transmit an internal explosion to the explosive mixture from outside the enclosure. Stand for determining the maximum surface temperature. The stand for determining the maximum surface temperature is used for measuring the maximum surface temperature of explosion-proof electrical equipment with flame-proof enclosure type of protection and increased safety type of protection, with a maximum power of 1 kVA. The stand comprises an adjustable power supply, an Agilent multimeter with thermocouples and a computer for equipment commanding and acquisition of data resulted from the test. Depending on the equipment's type of protection, measuring the maximum surface temperature is performed on internal surfaces or on external surfaces of the equipment. Stand for testing equipment with intrinsic safety type of protection. The stand is used for testing equipment with intrinsic safety type of protection and for determining energetic parameters of supply sources with intrinsic safety type of protection. In operation, there are generated sparks inside the testing chamber where the explosive mixture is located, mixture consisting in air and flammable gases, such as methane, propane, ethylene and hydrogen. If the sparks generated by the energy provided by the tested equipment do not ignite the explosive test mixture, then the equipment passed the non-ignition test. The sensitivity of the test stand is verified through the calibration process, in which the test mixture has to ignite from the sparks generated by a supply source which has imposed electrical parameters. Stand for testing equipment with pressurization type of protection. The stand for testing equipment with pressurization type of protection comprises the following: an installation which transfers the testing gas within the pressurized enclosure to be tested, helium and carbon dioxide bottles as appropriate. Part of the stand is also the equipment for measuring minimum and maximum overpressures and the purging time. The tests are performed in accordance with a specific procedure accredited by the Romanian Association for Accreditation and in accordance with the European Standard 60079 second part. Usually, tests are performed at the manufacturer for large-size equipment, but there can be situations in which the tests are performed in the laboratory. Pressurized chambers come to cover the situations in which there is a large number of normally constructed equipment in a certain enclosure, and the cheap, fast and efficient solution is for the chamber to be pressurized. The minimum overpressure which has to be maintained during the entire operation time of the equipment and for a pre-established time after is lower than the one for pressurized equipment, taking into account that in this case the intervention of human factor inside the enclosure is also needed. Stand for testing primary and secondary cells intended to be used in explosive atmospheres. The stand is used for measuring the surface temperature of batteries and accumulators intended to be used in explosive atmospheres in low current installations. After confirming their capacity, each component is usually subjected to a short circuit regime. During the test, there is monitored the value of the surface temperature measured in the middle of the lateral surface of the tested component. The temperature peak obtained from recordings is corrected with the value of the difference of ambient temperature to the maximum ambient temperature of use. The maximum surface temperature value obtained, corrected for an assembly of 10 components, represents the final result of the test. Stand for mechanical tests. Taking into account the explosion hazard from atmospheres in which operate certain technical equipment, we can highlight the importance of this equipment to operate properly and to ensure the conformity with the specific requirements applicable for each product. Mechanical requirements materialized by tensile or compression tests for ensuring the conformity of technical equipment operating in potentially explosive atmospheres have a considerable weight in the process for certification and placing them on the market. For assessing the conformity of technical equipment with the applicable safety requirements, There are necessary laboratory tests for mechanical characteristics, in compliance with applicable standards. There exists a wide variety of technical equipment which, in order to operate in potentially explosive atmospheres, have to ensure the conformity with mechanical resistance requirements. Of this wide variety of equipment we can mention the following: electric cables, lamps for underground, footwear as part of personal protective equipment, pipes, breathing devices, and so on. The test stand consists of the universal machinery for tensile, compression and stretching tests with serial PC interface and software for data processing, which ensures multiple analysis characteristics for the mechanical tests mentioned. The software is a completely integrated package and supports all industry standards, including the European standards transposed into the Romanian legislation. It provides simple or complex tests over several stages defined by the user for the specialized testing requirements. Tests for determining the characteristics of dusts. KSEP 20L stand. The KSEP 20L stand is used for determining the explosion indices in flammable dust-air mixtures. The determination of explosion indices in flammable dust-air mixtures is carried out in accordance with the following European standards: 14034 Part 1, 14034 Part 2 and 14034 Part 3. Knowing the explosion and combustion characteristics of dust is required for proper choosing, development and correlation of prevention and protection to explosion measures. The KSEP 20L stand allows the determination of explosion indices such as maximum explosion pressure, maximum rate of pressure rise, explosion class of the tested sample, lower explosion limit and the minimum ignition energy for flammable dust. By whirling the dust sample inside an explosion-proof vessel type KSEP 20L and by igniting the cloud in initial temperature and pressure conditions given by the standard. Modified Hartmann tube. The modified Hartmann tube is used for the classification of the dust sample, flammable or non-flammable. Qualitative pre-testing on the behavior to explosion of the dust-air mixture. The modified Hartmann tube allows qualitative determination on the behavior to explosion of the dust-air mixture. By whirling the dust sample inside a glass tube, type Hartmann tube, igniting the mixture from a continuous source with enough energy, viewing the phenomenon and recording it using an electronic device type active flap located in the upper part of the glass tube. Stand for testing blasting machines, devices for initiating the blasting circuit. In order to perform blasting works in safe and reliable conditions, the blasting machines have to operate properly and to ensure the conformity with the protection to explosion requirements. Blasting machines are electrical devices aiming to electrically initiate the electrical detonators, generating an electrical signal in the form of capacitive discharge. One of the most significant parameters for a blasting machine is the energy output. The blasting machine has to provide enough energy to initiate the entire circuit of electrical detonators. The presented stand comprises a 1 GHz oscilloscope, an OMEX aiming to simulate the resistance of the blasting circuit. Electrical signal generated by the electrical detonator is shown as an oscillogram on the screen of the oscilloscope. Recording the oscillogram is very precise due to the oscilloscope's high performances. Characteristics of the recorded oscillogram shall be analyzed and interpreted. There shall be performed calculations and written in a primary record sheet, and afterwards there will be obtained the results of the test for determining the energy output of the blasting machine. Dust chamber. The dust chamber is used for verifying the first digit of the normal degree of protection, IP code, protection to dust ingress inside technical equipment. Using the dust chamber, the following characteristic digits can be determined. IP5X, dust protected. Ingress of dust is not entirely prevented, but it must not enter in sufficient quantity to interfere with the satisfactory operation of the equipment. IP6X, dust tight, no ingress of dust. Talc powder is used for performing the tests, 2 kg for 1 cubic meter of the test chamber, in compliance with the requirements of the European standard 60529, the chamber being fitted with a dust circulation pump for maintaining the talc powder in suspension. Depending on the type of enclosure of the electrical device, first or second category, equipment to be tested are located inside the testing chamber and the vacuum pump is used or not. For first category equipment, the test is performed at a depression of maximum 20 millibars. Second category enclosures shall not be subjected to such a depression, and the test will last for 8 hours. Any normally open exhaust hole shall remain open during the test. Stand for drum friction testing of conveyor belts. The stand is used for determining the resistance to friction over the drum of conveyor belts with textile and metallic insertions, intended to be used in potentially explosive atmosphere and in the mining industry. The drum friction testing of conveyor belts is carried out in accordance with the European standard 1554. Principle of the method. A conveyor belt sample is wrapped around half of the circumference of a rotating steel drum, simulating a jammed conveyor belt. The test is carried out under certain strains and over a given time period or until the belt breaks. The presence or absence of the flame or glow is noticed and reported, and the maximum temperature of the driving drum is recorded. The test is performed in still air or in airflow. Voch 7060 Climatic Test Chamber. The laboratory disposes of a climatic test chamber type Voch VC 7060, used for climatic conditioning both for temperatures and for humidity. In order for equipment to be certified for operation in atmospheres with explosion hazard, they have to ensure the compliance with specific standardized requirements. In this regard, very precise laboratory tests have to be carried out, in order to have the best results required for conformity assessment. The climatic test chamber type Voch VC 7060 is able to perform temperature conditioning ranging between -70 degrees Celsius and +180 degrees Celsius, and humidity conditioning ranging between 0 and 99%. The space used for conditioning is 600 cubic decimeters. There is also a possibility for conditioning certain equipment during their operation, for example lamps or LED projectors.